Alright everyone, Shivam back here again with another problem, and this time it is with projectiles, the projectile motion or trajectory. So let's start off. Okay, so we have the question up here on the board. So Shivam, I am playing snooker and is attempting a massive shot. The shot is made on a 12 feet by 6 feet table with initial velocity of 0.9144 meter per second. If the cue ball and black ball are on the exact corners on the same side of the table, what should be the shooting angle to pot the ball? Additionally, what will be the speed of the cue ball right before it hits the black ball? Now we have given some instructions. We have to assume that the table is standing vertically. It's not on the legs, it's upon the rails. It's standing upon the rails, not the legs. And gravity is still applicable. We have to disregard any kind of resistance that is acting on the ball, on both of the balls. And we do not round until the end, and the answer should be calculated with respect to feet. Alright, so let's start off. So right here I've got an image of how the table would look like. I kind of added 3 balls in the center so that it's like a trick shot that I'm trying to attempt on. Okay, so we have got the length right here, which is referred to as the range, I believe I will say, which is 12 feet, and the height, which is 6 feet. Now it is the length of the table, but here in this figure I'm assuming that it's the length between the cue ball and the black ball, which is 12 feet, and the highest position I can get when I shoot the cue ball to make a massive shot, which would be 6 feet. That's what I'm assuming right here. Now there are 3 balls here for no reason, and there's a trajectory or a path or a parabolic line that shows how my cue ball is going to look like, the cue ball's path is going to look like when I shoot it. So let's see what information we have. So we have the initial velocity, which is 0.9144 meter per second, which I converted to 3 feet per second. And it's viable and plausible to see how after each and every second the position would look like. Then we have the final velocity, which we assume as 0. I'm at least assuming as 0. R, which I say is the range, is 12 feet. Range is the length between the cue ball and the black ball. Cue ball and the black ball. Height is 6 feet. Height is the highest position I can get by the cue ball's path, which is assumed till here, which is 6 feet. Now acceleration in the y direction or gravitational acceleration would be negative 9.81 meters per second squared, which is equal to 32.185039 feet per second squared. Now what we have to find is theta, the angle when we want the angle that we want to shoot the cue ball with, and the final time it reaches or attains right before the cue ball hits the black ball. So the cue ball is this right here and the black ball is this. So we want to find the time when the cue ball hits at this point, right before it touches, like at the split point second or something. Now what we can do is we can first quickly find the speed at the end of the whole path, which is the speed right before the cue ball hits the black ball. Now, since the question said that the table is not standing on its legs, meaning it's standing on its rail rather than the normal, which is like it should be standing on the legs. Gravity is acting upon it. Now, when the shot is made with a velocity of 3 feet per second, the final velocity right before the touch between the cue ball and the black ball will be decreasing. So since all the velocity is always decreasing in the symmetrical manner. However, the speed decreases until the highest point is reached, and then it gradually increases with the same acceleration that we have from the beginning, which will be gravitational acceleration. Alright, so it creates a parabola, and the parabola has opposite signs but same values for the position. So if I wanted to show you on the diagram here, let's say for example this parabola is symmetrical. Rather, I know that it's not, but it's assumption that it's symmetrical. Now the parabola has its own kind of characteristic, where if I have a point here, let's say for example 1,3 on the left side, or actually let's say if I have a point at a negative 1,3 on the left side, and this is the 0 line, the y-axis, my second point on the parabola would be 1,3. So it's opposite signs but same values. The values have not changed. That's the same with speed. Speed decreases until this position and gradually increases until this position. So hope that makes you understand what it means. Alright, so we got the answer for the second question, that was like what will be the speed of the cue ball right before it hits the black ball. So there we go, it's going to be the same as the initial one, simply the same. So if I hit the cue ball with 3 feet per second as the speed, as initial speed, the final speed would be the same. Now what we have to find is the shooting angle. We are given that the initial velocity is 0.9144 meter per second or 3 feet per second. We can use that and construct a right triangle, something like this, where theta is provided on the left, the right angle is in this area. I can even label it like A, B and C, and we are provided with the sides, the V initial on the x direction velocity, that's velocity, initial velocity in the y direction, and the actual or resultant velocity, which is 3 feet per second. Alright, now on this basis I can create something like this. We know that SOHCAHTOA, sine is equal to opposite over adjacent, cosine is equal to the adjacent, sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So I basically use this tangent, which is equal to opposite over adjacent. In this case, it's going to be initial velocity of y direction over initial velocity of x direction. Alright, so the reason why I used it, so let's say if we assume that the starting point is 0, 0, okay, and with 3 feet per second of velocity, after 1 second the position is going to be 1/3. So how? It's just simply I'm using the velocity time graph, like where velocity is equal to the length traveled over time, the distance or displacement. I think in this case it should be the displacement over time. Alright, yeah, so hopefully that makes sense. In that sense, this is the slope, which is rise over run, where rise is sine of x, which is like opposite over hypotenuse, and run is cosine of x, which is adjacent over hypotenuse, with respect to theta, of course. And in that way, the opposite side and adjacent side would be 3 and 1. So opposite equals to 3, sine equals to 3, and cosine equals to 1. That brings us to tangent of theta equals to 3/1. Now, since our task is to find out what the theta is, theta, which is the shooting angle, we can use tan inverse to solve for it. So theta equals to tan inverse of 3/1, and if you plug that into your calculator, tan inverse 3/1, I get 7.56. That's my angle. That's what I will be shooting my cue ball with to get the pot successful. Now, this is 71.56 degrees. If we wanted to cross verify this whole triangle theory that I just said, we can cross verify it using Pythagoras theorem, which is a squared plus b squared equal to c squared. Alright, so if you want to, you can just look through it, and I can actually walk you through over this. So simply what I mean is I'm ignoring that there's a 3 here and assuming a equals to 1 and b equals to 3 from the above things that we did. Now, a squared plus b squared is equal to c squared. That's the Pythagoras theorem rule. So 1 squared plus 3 squared equal to c squared, which gives us 10 equal to c squared, and square root it on both sides gives you 3.16 and some digits after 16. Now that could be rounded off to the nearest integer, and that brings us to 3. So hence proved that, yeah, it's cross verified, verification successful. So the final answer is theta is equal to 71.56 degrees, and there you go. Hope this helps.